Hello, this is Sean from Twitter. Today we're going to talk a little bit about the ROP. I have made a video in the past talking about 1.76 ROP and the gadgets for the ROP, which are present in libc, libkernel, and also libsce WebKit 2. But today I'm going to talk about something that's also related with the ROP that not a lot of people know about, which is about the bytes that are present in the gadgets. So, for example, you can see here the gadgets. Here you can see pop RBP, and you can see it goes to the byte 5D. To find this byte, you must open the WebKit 2 database. So you go here, then you go to this offset P5D6D. You just copy it, and you click on G on top of the text, and you go here. And if you go to the hex view, you can see that it's 5D C3. So you can just copy here and you put here 5D C3. And for example, for pop racks, it will be the same. So instead of 5D C3, it will be 58 C3. And you can just go to the WebKit module again. You go here to the same one, and it will be 58 C3. This works because C3 is a return and ROP is return-oriented programming, and you just find small gadgets that do the instructions that you want, and then after that a return, because you know that they will do those instructions, then return, and then finally you can use it to build a ROP chain, which then can be used to achieve code execution. So, for example, this one, one of the most complex ones, 4989 CA0F05. You know that after these bytes there's a C3. So if you go here to libkernel to 457, just go here and press G and go to 457, and you go to the hex view and you just compare. You can see 4989 CA 0F05, and then finally C3. So you can just put here in the comments that they will be the same as the bytes here plus C3. So if you just check here, they will be mostly the same. For example, here move racks DH. You just go here to the WebKit 2 to this offset, and you just check where it is. For example, which is 8830C3. You could do the same here. It will be the same, 8830C3. There are several. They will always be like this. So this one will be 48, 89, 87, 88, and then 3 0 bytes, and finally C3. It's mostly the same stuff. There is an exception, of course, this byte, which is red. And if you go to the WebKit one, if you go to the WebKit and you press G and you go to this one, it will point directly at C3. So you can use any C3 byte of the bytes that you have here. For example, if you want any other byte, and it's also important that these bytes are located in a text segment. So if you go here to the IDA view and put on text view, you can see here that it has a code segment. So if you go here, this will be where the data segment is, strings, and you can't go from here. You need to be on the code segment, which is where the instructions are. So that's also important. So these are the conditions to have a rob chain. You find the gadgets, all these, and then you build a rob chain to make your own code execution via userland. This is always the same thing, and of course, if you search for pop RBP in these offsets, you will know that also pop RBP. So not in libkernel but in WebKit. You just go here and you go to IDA view and you can see it's pop RBP and then return. Always like that. If you go to another, if you go move R10 RCX syscall, it will be move R10 RCX syscall and then return at 457. If you go to move RSI RCX, it will be move RCI RCX and then return. Always like this. If you go to call RAX, it will be call RAX and then return. So 48C3. Always like this. And that's all for today's video. I hope you guys enjoyed it. For I believe that C30 is the only person that made the bytes of these instructions show up because well 1.76 was very simple back then, and the most recent exploits are very complicated, but it helps a lot to understand what the gadgets do, what the functionality is, which functionality is necessary to produce the rob chain. Of course, these gadgets are needed for the exploit to make the proper functions to load a payload or something like that. So it's important to know what these bytes mean and what they do. If you go to the browser and you search for x86 to hex, you can see that they will be the same. You just go here and put pop RBP. You know it's x64, and you just click assemble, and you can see it's 5D pop RBP. So you can just search for any that you want to look. For example, pop RDX. You want to go to pop RDX. Let's see if it's really 5A FFC5. So we just go here, pop RDX X64. Well, in this case it's just 5A, but I believe he used another type of instruction for 5A, but you could also use 5A for this. but use this maybe for some kind of specific instruction. But let's do the opposite. Let's just put here 5A FF C5 and let's see what happens. We'll disassemble, and as you can see, it does these following instructions. First one is pop RDX, and the second one is inc EBP. So it uses it for this specific instruction. Okay. So yeah, that's all for today's video. I hope you guys enjoyed it, and I hope I give you enough strength to do this ROP stuff, because it's fun stuff. You can do it with an exploit that you have on your own PC and test it on a vulnerable WebKit. And I will see you on the next video.